and because this is very futuristic product. And Kubernetes, the way it came in the shape and form it came in 5 years back, the Kubernetes today is quite advanced, quite robust, backed by uh, a very important foundation called Cloud Native Computing Foundation, CNF. Okay, it's an open source container orchestration system. Container orchestration. So you are already in the state of the art technology with Docker, and then you are managing that, which where the Docker ends, Kubernetes starts. So it is like that. So it will help in automating application deployment, scaling, and management. That management is a very important aspect. You can deploy with so many other tools are there. You can perhaps scale as well, but managing your deployment over automatically over a huge network, a cluster of network is not a small thing. It needs a lot of uh, that tool. The Kubernetes will help almost 90% of it. So the Kubernetes can do a lot of things. First of all, the rollout management, that is, we are now so experts in blue green deployments. It is because of the uh, you know in the deployment there is a thing called a rollout and a rollback mechanism. You can smoothly roll out without disturbing the existing running platform. That is, you are upgrading a version from version 1 to version 2, but without a downtime. That is a big achievement. Earlier, you need to have a downtime, and see in this competitive market today, even a 5 minutes downtime is going to cost you millions and millions of dollars. So you cannot afford leave aside a day's downtime. You cannot afford even a 5 minutes downtime today because of the business implication. Okay, so you have to have a mechanism where you will deploy your new functionality, new patches, okay, but without disturbing so the end users who are using your system currently will be absolutely unaware of that there has been a total upheaval or the total rollout of a new system without their knowledge. That is possible with the blue-green deployments or the rollout management of Kubernetes. So resource bin packing is something like Kubernetes will automatically scale. That is, it will wherever the requirement of resource packing, like the CPU and the memory, you can in your deployment, as we learn in details about Kubernetes, you will see that there are manifest files. In the manifest files of let's say I'm going to deploy an application over microservices, over several pods, okay, and I can pack up the necessary CPU. I can set up a quota of CPU and the memory, the requirement within the package, within the deployment itself. And I can also specify that what is the threshold, that is whether at what level, whether it is at 80%, whenever the CPU and the memory usage reaches almost 80%, within a pod, within a single pod, you can pack up. So each pod will have a different requirement. So it will be managed automatically. Say a pod is already hitting that threshold, immediately there will be Kubernetes will figure out the best combination of how it can cater to the request that is coming in for that particular pod and how it can scale up. What is the best minimum critical path that it will adopt to uh, scale up, or in times it can scale down when the when there is not usage. So it is dynamic in its usage and requirement of scaling. Inbuilt service discovery and auto scaling, as you know, discovering a microservice around among the thousands and thousands of microservices running in a system is one of the most difficult hurdles or challenges. You see, to discover. So from outside, you are trying to get access to a particular piece of an application, and that might be very difficult when you consider there are so many pieces of applications and microservices running around, that to go to that particular piece of application for your requirement with the minimum of effort and the least path is the most challenging part of service discovery. With the help of Kubernetes, you can do that. And as we already discussed about the auto scaling. So there is also a support for heterogeneous clusters. That is within your cluster is you are the master of that cluster. But whereas if you are trying to combine the virtual machines running in the cloud or on premises, so there can be a hybrid cloud. So there is a mixture of cloud, or between the clouds, you can have an AWS cloud or an Azure cloud or a GCP cloud. You can have a combination of EKS, that means Elastic Kubernetes services, or Azure Kubernetes services. If you want to communicate with the servers distributed among all those clusters, it is also possible. So it can support heterogeneous cluster as well. Persistent storage is a very, very important fundamentals. It has expanded the functionality of Docker, where Docker has a Docker volume. Now, Docker volume has its limitations, but with the persistent storage, which is persistent volume, which is called PV and PVC, that is, you can declare or you can create a persistent volume by, say, using a service called PV. But the main important thing is the PVC, the persistent volume claims. You will make a claim to a storage. Okay. And that how you make a storage, how you apply for a storage, and how that storage will be serviced for you is a very important concept in Kubernetes. It does everything over some automation. There are 7 use cases why industry has adopted Kubernetes over anything else. I'm not going to go into details, but just for the heading is how to get your app up and running by deploying it on Kubernetes cluster. That is once that is you are the Kubernetes is a master of doing that. Kubernetes can orchestrate the microservices. Okay, so the applications distributed over microservices that can be helped. That microservice architecture can be supported over Kubernetes. Lift and shift. It is one of the important facilities that is, if you are trying to move from an on-premise application to the cloud, you can take the help of migration of that through Kubernetes. And definitely, as we said, it is supported by cloud native network functions. So that is why it is so robust and it is so standard. Security wise, it is very standard. It enables machine learning. That is, you will be able to deploy the AI based apps, smoothly and without any much hurdle. It is having a mechanism architecture to support that. Heavy computing. So it is catered to the future ages where you will be involving into heavy computing because of for the AI and other tasks. And of course, it can support, you can deploy your CI/CD pipeline with its entire jobs and tasks automatically over onto Kubernetes, and it will start performing very smoothly. If I generally, there are projects where you will deploy your pipelines over the Kubernetes and how smoothly you can integrate all your jobs. So the role of Kubernetes, it is basically to understand that we have moved from the monolithic application quite long back. It is almost 10 years back. We have moved out of monolithic applications and we are now into microservice applications. Okay, these are very tightly coupled. So front end is coupled with back end is coupled to the database. So all this is a single layer application. And because of this tightly coupled thing, there is a lot of downtime, because if something goes wrong in the front end, you have to you have to have a downtime of the entire application. Whereas the front end, the back end, the database, okay, all now are form of microservice. So even your database is a microservice application. It can be deployed over pods, or rather you can say abstraction of a container or a Docker container or a container. It's not necessarily it has to be Docker every time. So can you see that you can put in the entire database application as a client running onto a pod, and you can replicate the pod. So there is a high resilience, high availability, and the isolation. So all these are very, very acid properties of of database, which you can implement very easily over the microservices, and you can deploy it over Kubernetes. And there are lots of microservices will be in the pipeline as well. They are waiting. Many container services are waiting to be deployed, and they can be smoothly integrated. You do not need to overhaul the architecture. The architecture is such that it can be expanded. It can auto scale itself depending on the requirement, the network requirement, the resource requirement, all these things. And each of this environment is uh, created within the pod. So this can work isolated. No, no two pods will be tightly coupled with each other. That means it is not that if two pods are talking to each other over a pod network, does not mean that if one pod goes down, this will let the other pod also go down. No, they are not dependent. They are isolated and then can work independently. Hence, there is a need to maintain and monitor and govern the containers for their health and stability. Now, can you see that now there is a huge crowd of microservices because of the ease of deployment over the Kubernetes? You are deploying many containerized service over to the Kubernetes. Now the question comes about the health, about the availability, about who is going to know and how it is, what is the mechanism to know what has to be done in case of emergency, in case of disaster. What is the disaster recovery mechanism? Who is going to do that? Now there is a need. The more and more you deploy the microservices, more is the concern for the health of those microservices, and whether how easily you can first of all discover, then you have to monitor the health, and how fast you can take an action to recover the health if there is any problem. These are the management issues. Those things need a container orchestration in the way Kubernetes has been designed, such that these issues can be easily handled. You may please ask any questions if you feel so, because I am not being able to see you. I'm not, there's sort of a one-way traffic. Okay, because I have to cover a bit of things over today. Now, this is, you need the container orchestration tool. There are so many microservices. Okay. And these are basically the containers. Inside the container, you have the images or the application that is running, an application or a microservice that is running inside the container. And on top of the container, there is the layer of pod. Okay, we are coming to that. So the trend from monolithic to microservices and increased usage of containers, this has led to the orchestration necessity of orchestration tool like Kubernetes, because it will enable Kubernetes will enable high availability or no downtime. That is one thing. Scalability or high performance. Your performance will not go down. There is a mechanism for Kubernetes to understand whether the performance is going to be impacted or the performance is coming down. Okay. And of course, the disaster recovery, backup and restore. Now let us see Kubernetes in a bit of detail. Okay. I will be not going to that much of detail, but please remember this is the entire cluster. So I say this is a cluster of the master or the control node, control plane, as well as the worker nodes on which the jobs are deployed, the pods are deployed, the applications are deployed. So I will have, let's say this is one master node, and these are the two worker nodes. Worker nodes are, you can say these are also servers, but they are hosts or they are slaves. Slave in the technological term. This is the master in a technological term, not in human relations. Okay. So worker node 1 and worker node 2 are the two nodes in the system of cluster of Kubernetes. So why we say this is a master node? Because this is the heart or the brain of the entire Kubernetes cluster. Without this, these are your legs, your hands and legs, which will do the work. You will run the applications. You will handle the applications. Okay, over the pods. Now, the thing is, you are going to be needing a master, and the master has the main component. These are all components of the Kubernetes cluster. On the master node, you have the main, you can say this is the heart. This is the heart, the API server. Everything will originate from here. Everything will terminate over here. Okay. So these, you can say these are dumb machines. These are not intelligent. These are the slaves. The master is the one which controls everything. That's why it is called control plane. Okay. What about you? You can be a developer. You can be a DevOps engineer knowing Kubernetes. So you will be using a CLI, a front end. You will front end with the API server of the cluster. You can be a DevOps engineer. You can be an operations guy knowing Kubernetes, or you can be a developer. You may also be a tester. Anyone who knows Kubernetes can give certain kubectl. Now, kubectl, this is called kubectl. That is something that you need to install. We will install it over onto our server or the master plane. This will provide an interface between you and the cluster. It can be a dashboard, it can be a CLI, or it can be API based. And there are many tools which are available in the market which interacts with the Kubernetes as a dashboard, as an API. But we are going to use a conventional way that is provided by Kubernetes, so it is more powerful. Okay, we will use the kubectl to interact with the cluster. Now that is one part. The other part is, what about these? These are the components. These are the main components of your Kubernetes control plane, the master node. If this is the API server is the heart, this etcd is the brain. Now this is nothing but a database. A database which is a key value store. It does not store a lots of information, but it can store the informations in a JSON format, in a key value format, and it is called a key value store. It needs It stores all the information that is happening over in the cluster. So the API server will consult the HCD, this component, to give its the HCD will in turn give all the information that is available and stored in its database. Okay, because the API server will need further actions to be designed according to the data that has been given from HCD. HCD knows everything. What is the pod location in which node, or what is the pod running? Okay, what are the services that are getting run in each of this pod, or which is the pod network and how it can be communicated, whether what is the replication need for this particular pod. I mean, if this application is running in a set of 3 replica sets or 5 replica set or 7 replica set, all these informations are gathered over the HCD. And all HCD will also know whether one of the pods have gone wrong. What is the health? What is the health metrics of the pod over the worker node 1, 2, 3, 4, n number of nodes. All this information should be available over the HCD. It has a mechanism to collect that information. Okay, I will tell you what. So that information will be passed down to the API server. API server does like a manager, like a big manager in a big company. They do not do anything. They do not do anything, but they are the most important part of the organization, because through them, everything starts to be in orchestration. It is, you can say, this is the conductor in a big orchestra team where there are hundreds of musicians playing different instruments. Okay, this is the master, or the maestro, you can say, or the conductor of the orchestra, the manager, who will manage the entire show. Nothing will happen without. If this API server goes down, the entire cluster can go down. Okay, so we need to, again, can anybody tell me why I have given this shape? What does this shape resemble? When I'm saying this is an API server, what do I mean? Anyone wants to attend that question? Any guesswork will do? Any calculated guess? No one? Just try. These are also containers in their own right. So an application called HCD is running inside this container. It is particularly better to say this is also a pod. A pod is a abstraction layer over the container. That's a different question, but this is also a pod. This is a pod. This is a pod. All these are pod. So I can have replica of this pod. So if one API server goes down, one pod goes down, it will immediately can recover itself. It is like a zombie or something like that. What they say in English, I do, but they can self-generate themselves. They will never die. So if you had made an architecture like you have a replica of 3 API servers, which are pods, that's fine. So there are 3 pods available. You desire it. What will happen is one pod down, and the replica set will immediately set into picture and will recover or replace that pod, that faulty pod, with a new pod. So at any point of time, if you have desired 3 replica set of API server pod, you will always get the 3. That is the robustness. That is the, resilience of. So a Kubernetes cluster never goes down. It is a self-healing sort of thing. It can heal itself. It is a doctor of its own right. So immediately, and also, even if you have only one pod of API server, assuming that this will never die, you still cannot risk that it should be one. At least the HCD, because it's a database, and if data goes missing, API server can be crippled. Because if you do not get the right information, API server cannot take an action based on the data. So I need to at least have more than one replica set of an etc HCD pod. Clear? Then there is the scheduler. The purpose of the scheduler will be to schedule the pods running onto the on the worker node, on the worker nodes. So the scheduler will help to invoke the number of pods that you have desired, and it will maintain, it will schedule, it will maintain that pod running. So it will know once one pod goes down, and it knows through the API server from the HCD that this was supposed to be 3 replica set. So it will be immediately going and bringing up one more pod to make 3 by 3. 3 by 3 pods should be running at any point of time, because that is what you desired. If you needed that application to run 5 by 5, that is 5 pod running against 5 replica set, then you will always maintain that. Controller manager. Now, controller manager is something which has a lot of other uh, small, like the replica set, the replication manager, which is creating those replica set objects per deployment. Okay, for these pods, this will be controlled by the controller manager. It will be invoked. So if a replica set, if one replica goes down, immediately the scheduler will take the help of controller manager to invoke the replication manager to go and create that replica, that one replica which was down. So they are all working in tandem with each other. We will not say that they are separate. They are separate. Yes, they are isolated pods, but they cannot. It's like an orchestra. Each one is playing their part. Each one musician is playing their. I mean that instruments according to the tune of the music. They cannot go wayward. But the conductor is one guy who is managing the entire show. Now coming to the worker node, this is called the data plane, because you have deployed your applications, databases, whatever it is, over the worker nodes. Nothing will be deployed over here. You cannot use a master or the control plane for deployment of your application. Remember? And you do not need to do anything. You say, I would like to, you have given a deployment manifest file. And that is the manifest means you want to manifest your desire. Okay, you want to manifest your desire through a manifest file called deployment, called service, called secret, called config map. These are all manifest files. Okay, and that you will all create over the control plane, but those are objects created over here, but they are going to work on the various nodes. So you, whether you want or not, the pods will be deployed on the worker nodes, not on the master, because that will be governed and done by the scheduler through the API server, through the HCD, and through the controller manager. Now coming on to the worker node, you will install kubelet, kubeproxy, kubectl for all the worker nodes that you deploy, all the worker nodes. So each worker node will have kubelet and kubeproxy, and there can be so many other Kubernetes objects. Okay, but they all will work according to how the control plane asks them to work. Now, why kubelet? Kubelet is something who is the manager manager for the pods. So if anything goes wrong in any pod, okay, this will be first time the kubelet will come to know. This will be reported to the kubelet by the pod network. There is a pod network running between the master and all the worker nodes, so that each pod, like I can distribute an application over this worker node 1 and over this worker node 2. So 3 pods may be working over here and 5 pods of those of that. So I will have 8 pods, replica sets, three of them working on worker node 1 and 5 of them working on worker node 2. But they are the same application. They are the replica sets. So do you think that they are two separate servers? Yes, they are separate servers, but over a pod network, they are all connected. They are all working through. It's an orchestration of the containers. Okay. So you distribute your application over the nodes for high availability and better scalability. So kubelet is the manager who will know the health metrics of the container, of the containers or the pods. If something goes wrong, what will happen? Kubelet will pass on this information to kubeproxy. What is kubeproxy? Kubeproxy is the networking element of each of this. So your pod network will communicate with the kubeproxy, this object, okay, of Kubernetes deployed over on the worker nodes. Each worker node will have kubelet, kubeproxy. Okay, so kubeproxy is a network element or an object which will communicate this particular information that kubelet has given it to kubeproxy. This will go and inform API server. See, anything coming out or anything going in the master server is through the API server. The first information will go and hit the API server. API server will pass on that information and try to interact with the HCD to understand how many pods were replicated or desired to be replicated. The HCD will say, sir, I know there are 3 pods to be replicated or desired and working in this node. So we have to repair or make this one pod which has gone wrong up and running. That pod which has gone is gone. I have to create one more pod and replica, and so it will be in sync with the other pods. So the same application will be back again running in that pod. How will it happen? It will, the information passed on to API server. API server will contact HCD. HCD gives that information. API server will give that information to the scheduler. Scheduler knows how it will go and ask controller manager to ask the replication manager for the replica set, and it will go and hit the kubeproxy. Kubeproxy will get that information back to the kubelet. Kubelet will then help through the scheduler. It will help to get that particular pod go get back to life, or it will create a new pod, replacing the old and the depleted pod. Is that fine? Did you understand the workflow a bit? Maybe not in all. Any questions? So maybe there are end users. You see, you are the developer or a DevOps engineer or an operations guy interfacing with the Kubernetes cluster on the master cluster through the kubectl. You are giving commands, and the commands will be carried and processed through the API server. What about the end users? Let's say my end user or somebody who is trying to get an access to an application, or try to, because this application is running over the pods, I would like to get an access to one of the application. So the end users will request for a service. That request will come first. Where will it go? So I've given this in dash such that it is not misinterpreted. actually that request will first come and hit the API server, that bold line, that arrow. So they are interacting because the application is running on the worker node. They are basically interacting with the worker node, but through the API server. So that request, now the question is to discover that particular application. There can be thousands of microservices running on over the various nodes. You do not know where. The end user has no way to know, and it is not needed. They want a particular application to be run or to be accessed. So this request will come over here. API server will consult the HCD. HCD will, through the API server, will go through the scheduler. Scheduler has the least path to go and discover a pod through the service. Anyway, that is a technology that is there. So the service will discover the particular running application that the user wants. So basically, don't misinterpret this as it is going to hit the queue proxy like I have given. Yes, it will access the network, the queue proxy, but through the API server, of course. So the same architecture, that is a different view.
Mr. Devashish,
Yeah.
Paul have some question.
Okay, sure.
Yes, Paul.
Yep. Thank you. I was about asking question on the previous explanation. I don't know if you can like go back and display the flow charts.
This one?
Yes, perfect. Yeah. The what you explained is the relationship between the master node and two other nodes.
Yeah.
I just want to find out and to establish, is it should we assume that we can only have two worker nodes and pick one as a primary and the other one as a secondary, or in case we have a reason to expand our systems, is it possible to add other nodes apart from the
Fantastic.
master? Is it possible to add worker
Fantastic.
nodes, or we can really have just two worker nodes?
Yeah. So see, all these things are designed. I mean, this configuration, this Kubernetes has to be configured. If the architect, the solution architect will give all the parameters to you, and you as a DevOps engineer will design and create that cluster. Okay. The architect may say that there is a thumb rule. However big the Kubernetes master node be, but it should not cater to more than some number of nodes. That depends on the Kubernetes version that you are using. From version 17 to 30, this Kubernetes version ranging from 17, we have two worlds of Kubernetes: prior to version 17 and post version 17. That is from 17 to 30. These are powerful clusters. The version of 17 to 30 support power. So the thumb rule keeps on changing, that a one master node can cater to or manage or controls how many worker nodes. There is some, of course, there is, for better performance, you should not give n number of nodes. A cluster should be very balanced. That is one thing. And you will always have a room for the cluster to grow as per the, so it should be scaled up dynamically as per the requirement. These all the things can be configured. It is not that you will have one master and two worker nodes, and between the worker nodes, one is the primary worker node and the other is the secondary. No, there is no such relation. And as per the second question is, the worker nodes or a server can be provisioned automatically by the Kubernetes cluster. That is, auto scaling features are there. Okay, all these things can be configured. So if, let's say today you have a request for your applications, like some micro services which are like e-commerce application running, a very famous application. Today current time, there are 10,000 requests per second. 10,000 requests means the end users are firing requests, and that is almost like 10,000 requests coming at the same time simultaneously to hit your cluster, to hit your application. So there can be a load balancer in between the users and the servers or the cluster. You will implement a load balancer, and that load balancer will distribute the request. But let's say, yeah, between the worker nodes, because you remember your applications are distributed over all. So they are all part of the cluster. You cannot say this one is separate from this. Say your web application is running over here, your database application is running over here. Few of the web application is also running over on the worker node, this one, and few of the database application is also working on the worker node 1. So there can be a combination, and it can be distributed between the nodes. So you cannot say that the worker node 1 is totally separate from the worker node 2. And that to access this application, I will always need to go and hit the worker node 2, node 1. You do not decide anything. You just give the URL. That is whatever you want to access. The rest of the things will be decided within the load balancer. Load balancer will talk to the API server. API server will finally decide how to discover that application, whether it should access worker node 1 or worker node 2. There is called affinity, node affinity. Okay, that is a node affinity. And dynamically, there is a tainting of the node. Let's say worker node 1 is heavily busy. Almost 80% to 90% of the CPU and the other resources are already getting used. So it will start crying, screaming. It will say, please help me. I cannot take any more requests. Please help me. Because if you give me any further request, I may crash. So this is a very dangerous situation to happen. So before that happens, the cluster should take care of distributing. Just 1 minute. The cluster should decide to distribute the load or to make this worker node as tainted. You say you have tainted. This is a tainting mechanism. Because I didn't want to discuss all this. This is an advanced concept. Okay, but since you have raised this question, I'm saying tainted means you have protected this node for some reason, that this node is no longer going to accept any requests. So the load balancer, API server will work in between themselves and to make it tainted. And so whatever the rest of the nodes, the distribution of the request will be distributed over to this node or to some other nodes. So there is no question of this being the primary, that all the requests are going to hit this. No. There is no primary, no secondary. Everyone is primary, everyone is secondary, based on what the decision the API server takes. So did I answer your question? And if suppose there were two nodes.
Yes, perfectly. Yeah.
Okay, there are two nodes, and tomorrow, maybe 1 year down the line, your 10,000 requests now is 1 million. Requests. It has now, your application has become so popular that there are 1 million requests per second. Now, do you think these two nodes will be sufficient? And do you need to add one more node? You will not do anything manually because you do not know you have to depend on the cluster. You have configured it in such a way that you have configured the auto scaling groups. There is called the auto scaling groups. And for the Kubernetes, that means you will be doing some manifest file, configuration file. Okay, and saying that in these situations, whenever there is a requirement of a huge demand, and I need to horizontally scale. Horizontally scale means I am going to add a server. There can be a vertical scaling. It depends on how you see. Everything is on the way you want to design your Kubernetes cluster. Sometimes this can be beneficial. Sometimes this is beneficial. Horizontal scaling, that means you are adding up servers. Vertical scaling means you are going vertically. That means you are adding more CPUs, more memory, more storage. This memory and storage is different. This is the physical IO storage, IO, and this is the in memory cache. So this is very important. This is temporary. This is permanent. But this is going to be very much important when you are running something in the background. So these microservices are all running in the background. So this memory is very critical. So you may go for a vertical scaling. You may, from 8 CPUs, you may make it 16 CPUs, but all automated. You say at a threshold point of 80%, I will increment number of CPUs by say 50%. So from 8, it will go to 12 on 80%. Maybe on 90%, it will go to 75% of the number of CPUs. So it will go to say something like 14 CPUs. And on a certain, say 95% of the CPU usage, it can go to 100%. So in that case, it will be 16 CPUs. That is, it depends on how you want to configure. If that provides the best solution, that is okay. If adding a totally new server, a new node with a huge capacity, that can also be a solution. That is a horizontal auto scaling. Did I answer your question? But this distribution of the workload is entirely on the control plane. This control plane will decide, with the heart and the brain coming together to take a decision. Okay. But you can rest assured, whatever Kubernetes heart and brain is trying to decide will be the best for the system. It has to be the best. Any other question you may have? So node affinity.
I'm okay now, thanks.
Okay. There is a term called node affinity. Sometimes you will see if you have designated few of the nodes to be more node affinity, have a node affinity higher than the other nodes, then you have designed in such a way that most of your requests will be distributed to those nodes which has a node affinity. So this is just reverse of tainted. You are prohibiting any request to come to this particular node because you have tainted it, and you have made it a node. The affinity of this node has been created such that most of the requests will come to this. They work in just opposite manner. Okay, these are the two very important terms. So can I move ahead with your permission?
I can buy.
So similarly, I have given a different view, same view, but the diagram is the thing. So as I told you, your end user is whatever the request coming from the end user will hit the load balancer. Now this load balancer is either it is cloud provided network edge, or you are taking this load balancer from as a service from the cloud. So from AWS, you may have taken the ELB, Elastic Load Balancer. It may happen, but that is costly, a bit costly. As a DevOps engineer, you may want this to be an ingress load balancer that is coming for free. So if you are a good Kubernetes engineer, you will never ask your company to invest on a Elastic Load Balancer or a network load balancer from any cloud provider, because that is going to cost every hour. Load balancer are costly. So why don't you provide an ingress load balancer, an ingress which you can implement over the Kubernetes? That will be much cheaper and very, very efficient as well at the same time. We will discuss if time permits, but I don't think the time is there to go to that level today. So I will just finish up this one. We have like 20 minutes at our disposal. So the view is end user talking or the hitting the load balancer. Load balancer will distribute with some round robin logic or whatever, taking the help of Kube API server. See, ultimately everything is coming here and everything is going here, going outside and coming inside through the API server, Kube API server. So this is the master control plane. You can also have a cloud provider API that can be integrated or interfaced with the master plane. So there is, I will tell you, there is a cloud controller manager, but this is optional. Most of the Kubernetes architecture, you are going to see when I'm talking about this one. Sometimes you can go for a service of Kubernetes from the cloud, like that. For AWS, it can be EKS, Elastic Kubernetes Service. Then you need a cloud controller manager in the master plane. Automatically, it will be when you install EKS, a Kubernetes cluster over the Elastic Cloud, or that means the Amazon. This is from AWS. If it is, you have implemented something called AKS from the Microsoft Azure Cloud. Or this is from the Google Cloud provider, GCP. You have a Google GKE. Okay. So Google Kubernetes, I think extension or something like that. So this, if you take, but this is a costly solution. These are all costly solutions. Most of the customers that you are going to work, sorry, the companies that you are going to work with, or the companies, if they are rich companies, big companies, they may go for EKS or AKS or GKE. But in general, most of the companies will ask you not for this part. They will ask you to implement a Kubernetes cluster without the AWS provided or Azure provided or GCP provided the Kubernetes services. Okay. So this cloud controller manager will not come into picture at all. But if at all it comes, then I will remove this. Then you have something called a cloud provider API. You have to interact the control plane through the cloud provider manager or the cloud, what is that, controller manager. will interact with that service provider, either EKS or AKS. So I'm taking this out of discussion. So think that they are not there. Otherwise, whatever we have discussed remains the same. You see, on the node 1, you have a pod and you have a container runtime. So you will be installing Docker, both, because since these are also pods, these are also containers. So don't I need to install Docker? Yes. At the same time, when I install the Kubernetes cluster, I will install Docker over here as a container engine, Docker over the node, all the nodes, Docker. So this will be node 2. Okay. So because the Docker needs to be there to manage the pods and whatever the container runtime engine should be there. You see, this is a kubelet. And there will be kube proxy as well. So whenever you join this network, so you have to make that. Tomorrow you can add one more node. One more node can be added. Say node 3 into the cluster. So each of these node have to join the master. They have to join the cluster. It has to join the cluster. Joining the cluster means it has to make it enable to talk to the master node. This will also join. So all of them should be joining. And in doing so, kube proxy is the main component which will help in getting this joined. There is a kube proxy over here as well when you install the Kubernetes cluster on the master node. There will be a kube proxy installed here, kube proxy installed over all the nodes. These two kube proxies will help the node to join the master. That is what you say, joining, or you are expanding the Kubernetes cluster. Any questions? Now, as an overview, you have the Kubernetes master, you have the kube controller manager, and here it will be kube cloud controller manager. It will be I have missed out. This should be a kube cloud controller manager if you are using any cloud enabled services for like the AKS or the EKS or the GKE. But otherwise it is not needed. So you have the controller manager, API server, etcd, kube scheduler. Okay, these are the four main components. On the node, you have the kubelet, kube proxy. So this is node 1, node 2, node 3. And there can be a series, so many nodes can be there, but they are all part of the cluster because you say that everyone has joined the cluster. Okay, so the control plane and the worker nodes will talk to each other. So your worker node, so your master node has etcd, API server, scheduler, and of course a Docker engine. And all this will interface with the controller manager before it gets in or gets out. So the API server will communicate with the etcd, and API server will communicate with each other. API server will communicate with the scheduler. Scheduler will communicate with the controller manager. Controller manager in turn, it will talk to its other managers. So this is the boss. For some sub managers like the replication manager, and there are various other managers. Okay, so and then on the slave, this will be Docker, of course, Docker everywhere. And you have the kubelet and kubeproxy, kubelet, kubeproxy, kubelet, kubeproxy. Is that fine? That is the simplest architecture. Now the same thing, you can have, generally you will never go for a Kubernetes master other than Linux. That is on a Linux machine, on a cloud or wherever, on premise, doesn't matter. You will implement a Kubernetes cluster. You can implement it over on your laptop as well. Not necessary that you need to have a big server. So it is the size of the cluster that you decide on. How many nodes you want to get into that cluster, whether 2 nodes or 5 nodes or 10 nodes or 20 nodes or 100 nodes against one master. So the node components are your kubelet, container runtime, kubeproxy. Can you see kubeproxy having a networking element? This is a networking object. This can be on, of course, this node part can be on Linux, preferred on a Linux machine, or on Windows or Mac. So Kubernetes nodes can run on Linux, Windows, or Mac nodes. Kubernetes master runs on Linux nodes most of the time, because if you are in a company who does not have a Kubernetes master running on a Linux machine, on a cloud or on premise, then you know it's a small company. It is not even medium sized. So we have already discussed what is etcd. I will not go through it again. This thing will all be there in our site. This PowerPoint presentation. API server. We have discussed about API server. And then the scheduler. We have also discussed about scheduler, what it does. The controller manager, as you have said. Now, the controller manager, just one thing. The controller manager will have the other managers working for it is the node controller, replication controller, endpoints controller, service accounts, and token controller. So wherever there is a security and token, issue, that will be taken care by the controller manager through the token controllers. Where there is a service discovery, like you have to discover a particular service, okay, you can take help. The replication and the controller manager will take the help of service accounts. Endpoint controller. So endpoint controller is the mechanism to go fast and get into a controller which can take you to the endpoint of this is the pod. It can take you to that particular pod through this endpoint controller. So it knows the destination. The replication controller will create the replica set. So replica set is one of the objects within the replication controller. It is called replica set. So it is not only one single controller manager. A controller manager again is in turn will be helped by the node controller, replication controller, endpoints controller. There are so many managers, sub-managers you can see. Okay. So that is it. Kubelet. Similarly, it will be for the node. It's an agent. It monitors the activities in the worker nodes and communicates the health of the node to the master node and more specifically to the controller manager. So as I told you, the health of the pods, the health of the node will all be communicated through the controller manager to the API server. And finally, the kube proxy. Kube proxy enables port forwarding. Like it is in a service, you want to forward the port from one service to the other service. From the external port, how do you communicate to a particular service within that? It's a lot of things. It cannot be discussed. The scope is not enough to discuss Kubernetes in 1 2 hour session. Okay. Uh, so I will say that we will continue the discussion. It is not that it is the end of the session for DevOps today with the Kubernetes, but also Kubernetes. I designed 2 sessions for Kubernetes. We are ending up with one because uh, from the next weekend, we are going to start the cybersecurity in place of DevOps. So let us complete whatever, how much I can complete, but that is just, it is a tip of the iceberg. Kubernetes is a big subject. So many things to learn. So the kube proxy enables port forwarding of the services to the external nodes and master. Whenever we are deploying new pods or services, we need to forward port to communicate to other ports, because all these pods are communicating with each other. You do not say that they are isolated, but they are not aloof. They are working as a part of the application, bigger application. Okay, so they need to communicate with other pods, and that communication is through the kube proxy. You need to discover a pod. How will you do? You will contact the kube proxy. Kube proxy, with the help of your scheduler and the HCD and the API server, will find that particular service. Kube proxy is the network component. Deployments created and exposed as a service is possible for the kube proxy. It helps in exposing the services around the nodes and the pods. So, for each of the node and also for the cluster, I mean the master plane, it needs to have a support from the CRI. CRI is the container runtime interface. And this is OCI. OCI is the Open Container Interface as well. So it can be from Docker, it can be from Rocket, it can be from Mesos. The technology is container runtime engine. Whether it is provided by Docker or provided by Rocket or by Mesos, it will work the same way. What happens if the master node goes down or the API server component crashes? Will the applications running on the pods, within the pods, stop running? Who can answer this? Yes or no? Will the applications running inside the pods will stop running if the master node is not available, or maybe the API server has crashed? Will it immediately stop running?
Yeah, from my own service or service impression, I think it will not stop running.
Very good.
The master node, yeah, the application will select a particular worker node that will take the place, but it's going to be for a very short time, where
Exactly.
there will be a kind of a message that will be sent to the API for the master node to get fixed. I think it's supposed to be for the period of 24 hours. And once it's fixed, it will assume the duty of the master node.
Exactly. So it is only in a situation where your replica set, let's say the 3 pods are running, 1 pod goes down. So because the scheduler cannot work without the API server, so that pod which has been defective cannot be replaced with another pod in its place. So the replica set, which was supposed to be, you have desired that at any point of time that application should be in 3 sets of replica. So there are 3 replica sets on the node. 1 goes down, 2 left. Okay, will it be recovered to 3 because your API server is down? or the master node is down. So the 2 will not be graduated to 3, or the desire will not be met. You have desired 3, but right now it cannot be held because your master is down. So it will be 2. Then at one point of time, 2 nodes are down. Two pods are down. So now it will be only one left out of 3. But it cannot be 2 or 3 as per the desire, because you are not getting help from the thing. And at one point of time, one may also get down. So now 0 left out of 3. So in this case, the application will come crashing, because there are no applications running on any pods. It is not supported by the master. Okay. But yes, it may not go down. If it doesn't go down, then it will be keeping on till the time the master is up. It will still be able to work. Thank you for your brilliant answer. No, as the worker nodes and the pods continue to run, though no changes to the node or pod configuration can take place unless master node is up, and because your manifest file cannot work without the master. So I think I cannot go beyond this point of, because it is almost already time. So I'll park this discussion at this point only. There are a few things that is we will need to know about pod. Why we are not working with containers alone? Why we need a pod? Okay, sort of a replication. What is a replication set? What is a replica set? What is a deployment? Why do we not go for a replica set? Earlier, we used to use a replica set as our as an object. Nowadays, we have replaced it with after version 17, as I told you. It is now replaced with deployment. Deployment is a higher level concept that itself manages replica set. So I do not need to go for a replica set. Earlier, we used to create replica set objects. But deployment is a higher level concept that manages replica sets and provides declarative updates to pods. It handles updates in a controlled way. And that is where as we were discussing, the blue-green deployment, it is because of the rolling updates. So in a deployment manifest file, we are writing a deployment manifest. Manifest means what? You have a desire and you manifest your desire through a manifest file. Desire manifested through a deployment file. So there is a manifest file where you will write instructions of deployment, what you want to deploy. And in that, you can give the rolling updates and the tolerance level. That means up to what is the retry. Say you are trying to deploy something or update, a rolling update. You are updating from version 1 to version 2. Now, there can be an error or something like you are not being, so you have a retries, and at certain level of retrying, then you can roll back. You can roll back to the previous version. So this will happen automatically, smoothly, without your notice. And that is called a blue-green deployment. That is, it will not touch the existing application which is running. But gradually, version 1 will be replaced by version 2. That is a fantastic mechanism that you declare that within the deployment manifest file. What is the rolling update mechanism that you are going to apply in that in the pod deployment? Deployment makes a layer, say this is the container, okay? This is a container within which there is an image, but you are giving it a sort of a layer. This is called an abstraction layer. And who will give this abstraction layer? This is through the deployment manifest file. And this has a lot of advantage. Otherwise, containers as a single unit cannot work over a network. Docker, of course, Docker has a swarm. You have a Docker swarm, but this has lots of deficiencies. That is replaced with Kubernetes. Much more efficient. So through the Docker swarm, you can make the containers talk to each other, or you have a container network. Container network, but that network is not very profound, robust like Kubernetes. So I will stop my discussion over here today. You will still have how you will be deploying your applications in Kubernetes. What is the way deployment, then the pod, container, and the application is embedded within the container. So you have protected your application through these layers. It's a nice way. After deployment comes the service. Without a service, you will not be able to reach the pod which was deployed through the deployment manifest. So how do you reach? There are various external services, internal service. There is your node port service, okay, pod leveling. How will a service know a particular pod? The service will access the pod by the label that has been given. And then finally, we will have to learn about the ingress and egress. That is, we are installing, like I have told you, we will not implement the network load balancer or the elastic load balancer of the cloud because that is costly. We will implement ingress controller with an ingress service and the ingress rules. Fantastic design, but I do not have a scope to discuss all this about but in the main course, we discuss each and everything in details. So I will end the discussion over here. Okay, I think it was. I'm very thankful to all of you who have joined today amidst your busy schedule and on a Saturday morning or an evening. I am not sure where you are, but thank you very much for your dedication. This gives us a good. Yeah.
Thank you, sir.
Yeah, thank you.
Yes,
And
yes.
if you have any question, feel free to ask, because this month of November we are going to start 3-hour job ready training. One in data science in evening batch, cybersecurity in morning batch, cybersecurity and DevSecOps is morning batch, and DevOps morning batch. DevOps morning batch is, I think, is the end of November. Data science and AI and cybersecurity, I think, is middle of November. We are going to we can start. I think today is the last day of our DevOps internship program. It is like it went for last 8 weeks, so we will take some days break, and from the next weekend we will have our cybersecurity internship and AI internship. So AI internship will start from 7:30 a.m. Central Time or 8:30 a.m. EST, Eastern Time, or 6 p.m. Sorry, 7 p.m. IST time. Then from after 2 hours, we will start the cybersecurity one. So if you have any question regarding our training, our internship, or free or paid, or even anything about the job market, or if you are facing any issues with your or hurdle in your job hunting, any doubt, queries, feel free to ask. because we have a few more minutes. Okay then. Thank you for everyone for this joining this call. Let me know in the chat also. Have a great day. Thank you, Mr.
Yeah,
Devashish.
thank you all. Thank you.
Ernest, please
Thank
ping
you.
my WhatsApp. Yeah. Thank you, Paul.
Thank you, Paul.
Thank you, Mr. Devashish.
Thank you.
Thank you very much.